Chemical urine testing. The first step to urinalysis is the physical exam, which consists of color and clarity of the urine sample. Then we move to the second step of the urinalysis, which is the chemicals testing. This is also called a urine reagent strip. Urine reagent strips are a single-use plastic strip with various chemical reagents attached. When the strip is dipped into the urine, chemicals on the reagent pad react with the urine to form color changes. Two major manufacturers of urine reagent strips are Multistix and Chemstrips. Here is an example of what Multistix container would look like, and then the Chemstrip container would look like. There is currently a maximum number of reactions of 10 on the strip, so there are 10 different reactions that occur. 10 different pads is the maximum that these strips can hold. You will not need to know the reagents that each pad contains, but you will need to know which each pad is testing for. So the components of the dipstick and what the reagent pads are: specific gravity is one of them, and that tells us how concentrated our urine is. pH, so is it acidic or alkaline? Leukocyte esterase, which detects white blood cells in the urine in the case of an infection. Nitrites are formed when the urine is in the bladder for over 4 hours, and bacteria will then convert nitrates, which are commonly in the urine, to nitrites. So it's important that we try and get, if we're doing a culture and sensitivity for infection, that we get that first morning specimen, because nitrites would then be present. Protein, we also test for glucose for diabetics, ketones, urobilinogen, bilirubin, and then also blood. So the procedure, so once we collect the urine and we do the physical exam, which is the color and clarity, we would then mix the urine gently by swirling it with the cap on, observe color and clarity, and immerse the test strip briefly into the urine, no more than 1 second. Remove the strip and touch the edge of the absorbent towel. So place the strip in the analyzer and hit start, or for a manual method, you would begin timing immediately and then read the reactions at the appropriate time by comparing the color chart on the bottles. So here is a demonstration, some pictures that are demonstrating the dipping of the sticks for urine. So completely immerse all the chemical areas of the reagent strip briefly, not over 1 second. Remove excess urine from the reagent strip by drawing the strip along the lid or the rim of the urine container as it is removed, as such. And then once you have the strip completely removed, then you will blot it on its side on a paper towel or absorbent towel to remove any excess urine. Then you will want to make sure that you keep your reagent strip flat or parallel with when you're reading it manually. We do this to ensure that the pads don't bleed in colors, so they don't bleed together. Recording of results, we use negative or neg, normal or norm, positive, we abbreviate as POS, and then sometimes we will record results as trace, 1+, 2+, or 3+. So reading each chemical reaction at the time stated, this sometimes can be tricky, as there are a couple of tests that have to be read at the 1 minute mark. And so we have to be rather quick at doing this in order to ensure accuracy. You would not want to hold this upright like shown here, but you would want this parallel with your surface so these pads do not bleed together. So what you would do is, the timing is really critical, and you want to make sure that you hold the pads so you can read them rather quickly. You want to line them up, but make sure you don't touch the actual bottle with the reagent strips. So hold the strip close to the color block at the chart supplied by the manufacturer. And what I oftentimes will do is, as I'm reading these, and this goes rather quickly, and then there's a break before we read the leukocytes at the very end, is I will only note in my head the abnormal results. The ones that are not normal, I will note those in my head, so then when I've completed this, then I quickly write down what was abnormal about it, and then I know that everything else is abnormal. So just a little thing that I do to remember the results, because it is impossible to read it and write it and get the timing down. That does not work. Test only properly collected and labeled specimens, so specimens should be labeled on the container. In some facilities do like the top of the container also labeled. Allow refrigerated specimens to reach room temperature before testing. If they have been in the refrigerator, they should be out for an hour to reach that room temperature before testing. Otherwise, the results may not be accurate. Follow manufacturer's instructions for dipstick procedures and readings, which we just went over. Handle the dipsticks at the long end. Do not touch the chemical pads. So it's important because if you touch the chemical pads, it can alter the results of the test due to maybe a chemical reaction on your glove or your finger. Keep color chart clean and not touching the dipsticks. Do not use the strips beyond the expiration date, and keep the strips in the bottle tightly capped until you are using them, and then replace the cap right away after you are done. Precautions, so must be followed. Manufacturer's directions must be followed. Storage, oftentimes we store these at room temperature, in a dry place, not in direct sunlight, away from moisture. We also should keep the strips away from chlorine, bleach, or hypochlorite. They should not be stored in the same area. And Multistix has a white packet in the bottle. This is a preservative. To note that the bottle is black in color to protect the strips from sunlight. The Chemstrip has a Desiccant in the bottle of the container, as you see here. The white solid container also is protected from the light. Actually, this is cardboard and then it's colored white. Sources of error within the chemical reagent strips. There are a couple different things. Testing cold specimens, inadequate mixing of specimens, so if you forget to mix it, over dipping of reagent strips, so taking too long, so dipping it more than 1 second, inadequate blotting, forgetting to blot it on the paper towel so the pads will then bleed together. Failure to keep strips horizontal. This will also cause the pads to bleed together and you might get inaccurate results. Improper timing of tests. This is usually what happens, especially with students just starting this procedure, is they try to write down the test results as they are reading them, and oftentimes there's not enough time to do that. So we highly recommend that you just note the abnormal ones when you are reading them, and then you know that everything else is normal. Inadequate light and misusing the color chart. So I've sometimes had people use the color chart backwards and line it up backwards. So make sure you start with the bottom of the stick closest to your hand and start reading from there. External quality control. Normal and abnormal quality control should be ran once each day and when a new vial of test strips are open. If results are not within specific ranges, repeat testing using a new strip. Never report patient results until QC problems have been resolved. So these are external controls, so there will be vials of known values of these controls. And so we have to be within a certain range in order to run a patient test off of those reagent strips. So patient reference values, normal urine is negative for glucose, ketones, bilirubin, nitrites, leukocytes, and blood. Normal urine is negative for protein. Sometimes there can be a trace of protein, and that is okay, but anything beyond that is not. Normal pH is 5.0 to 8.0, with the average being around 6.0, so a little bit acidic. And that is to help deter pathogenic microorganisms from entering the urinary tract. And normal specific gravity is 1.005 to 1.030, so 1.005 meaning a well-hydrated patient, and a 1.030 meaning a more dehydrated patient.